In example 11, they ask us to find the second derivative with respect to x of cosine y equals x. So let's start with that function, cosine y equals x, and we're going to take the derivative of both sides. And so cosine y is a composite function. Y itself is a function. And so we're going to apply the chain rule on the left side. The derivative of cosine is negative sine y times the derivative of y, the inside function. That gives us dy dx. And then the derivative of x with respect to itself. And so we have negative sine y times dy dx equals 1. And solving for dy dx, we get negative 1 over sine y. Now you may recall that the cosecant of theta is equal to 1 over sine of theta. So we could rewrite this as the negative cosecant of y. Now to find the second derivative, we're going to differentiate both sides. And so we have the second derivative of y with respect to x. That's d dx of dy dx. And that's going to be equal to the derivative of negative cosecant y. Okay, so d theta cosecant theta is equal to negative cosecant theta times cotangent theta. So this will be negative cosecant y times cotangent y. And again, I need to apply the chain rule, taking the derivative of the inside function, which of course is y. That gives us dy dx. And you may remember from last time that we can't have a differential in our second derivative. And so I'm going to go back to my dy dx and substitute negative cosecant y. So this gives us a positive cosecant y times cotangent y times negative cosecant y. That's going to give us negative cosecant squared y times cotangent y. That's going to give us, let's see, negative 1 over sine squared y times, and cotangent theta is equal to 1 over tangent theta is equal to cosine theta over sine theta times cosine y over sine y, and that is equal to negative cosine y over sine cubed y, and that is the second derivative of y with respect to x. The thing that bothers me is that I don't have an x anywhere in here. It's all y's. But if we go back to our very first equation, cosine y equals x, I see that I can rewrite this. And so that's going to give us the second derivative of y with respect to x is equal to negative, and instead of cosine y, let's put x, because that's what cosine y is, negative x over the sine cubed of y. And there we are.